Using the general approach to mesh analysis, determine the current through each voltage source. Okay, we are asked to use mesh analysis, so let's draw the loop, right? So I will use this loop here, which is clockwise, and I will name the current in this loop as I1. And I will also use another loop here, which is I2, which is also clockwise. And we need to do KVL at I1 and I2. Let's start from KVL at loop 1 first. Let's do KVL at loop 1. Okay, what does KVL say? KVL said that the sum of the voltage in a loop will equal to 0. Okay, let's see here for loop I1. Okay, the loop here is entering this 12-volt battery from the positive terminal. So we will have positive sign. So I have plus 12, or I just write it 12. Good. And we will have plus 4, and the only current that pass through it is I1. So I'll have 4 I1 because resistance time current is voltage, right? That is the Ohm's law. Okay, and then we will have plus. We will have 3 ohm here, but we will have I1 and I2 pass through this R2 here. But we are working on loop 1, so I2 always came first. So we will have I1 came first. I mean, we are working on loop 1, and so I1 always came first. But here I2 is flowing to the opposite direction of I1, right? So I1 going down, I2 going up. So we will have minus I2. Good. And then we have one more component, which is this 15-volt battery. And the loop is entering from the positive terminal, so our sign will be positive. And the voltage is 15. Okay, good. All of that will equal to 0. Okay, now let's simplify this. 4 plus 3 is 7, so I have 7I1. And then we will have minus 3I2. Okay, and then 12 plus 15, that will be 27. And move it to the right-hand side, so I have minus 27. Good, let's save this as equation number 1. Okay, now let's do another KVL, but this time at loop I2. Let's do KVL at loop I2. And again, the sum of the voltage in a loop will equal to 0. Okay, the loop here is entering from the negative terminal. So we will have negative sign. And the voltage here is 15. So I have minus 15. Then plus, we will have 3 ohm here. And we are working on loop 2 currently. So I2 always came first. That is our prioritization. So I'll have I2. Okay, here I2 is flowing up, but then I1 is flowing down, so I subtract I1 from it. So I2 minus I1. Good. And then the last component is this 12 ohm resistor. So we'll have plus 12, and the only current that pass through it is I2. We'll have I2 here. All of that will equal to 0. Good. Now, I1 only comes from here, so we'll have minus 3I1. And then we will have plus 3 plus 12, that will be 15I2. And let's move this minus 15 to the right-hand side, so I will have 15. Let's set this as equation number 2. Okay, now we need to solve equation number 1 and number 2 here to get I1 and I2, right? So we'll have to solve 1 and 2. Okay, the fastest way to solve that is by using calculator. Okay, so we will have, let's set this as equation solver, this button, and equation solver is number 5. 2 variables is number 1. And let's plug this in. So I have 7, then minus 3, and then minus 27. and then we will have minus 3, and then 15, and then 15. Okay, we will have I1 here. I1 is minus 3.75. So I will have I1 is minus 3.75. And the unit here will be in ampere. And what is I2? I2 will be the Y value here, and that will be 0.25. 0.25 ampere. But the question is not asking us about that, so we need to answer the question here. Answer the questions. What is the question? The current through each voltage source. Okay, the current through each voltage source. So we will have this current here, which I will name it as I that pass through E1, right? Because we know that I1 here is minus 3.75. So the actual current is the opposite direction of this, right? This is going up, so the actual current is going down. So I will have the current that pass through the battery E1 here, that will be minus I1, and that will be 3.75 ampere. And that is the current that pass through this battery. And then for E2 here, I will name the current here, this one. That will be, I think we will have IE2, right? So we'll have IE2. And what is IE2? IE2 is equal to the one that is have the same direction is I2 here. So I'll have I2 and then minus I1. Okay, what is I2? 0.25 and then minus I1. I1, so I will have minus 3.75. So I have minus 3.75. 0.25 plus 3.75 is 4 ampere. And that is the answer for this question. The current that passed through E1 here is 3.75, and the current that passed through E2 is 4 ampere. Okay, I think that's all for this problem. Hopefully I did not make any mistakes for this question, and thank you for watching. If you got any question, send me your problem, rdsatria11@gmail.com. Hopefully I can respond to you as soon as possible. Thank you for watching and see you in the next video. Bye bye.